So we have covered that is the we have just started with a small test, right? And in that we have covered the first two small tests. That is the first one we have discussed about the t distribution, right? And we in that again we have covered all the tests of the t distribution, and the next is the chi-square test. So we have covered that is the total all that three chi-square tests. Next is the F distribution. Now there is only one F distribution test is there. Okay, there is no any types are there. Okay, so it is just a small simple things. Okay, so we will just start with this now. So what is the meaning of the F distribution first? Okay, I will share my screen to you all first. And and thank you. I also appreciate right your patience, right? That is from the 2 hours you are continue listening this session. So I appreciate that, right? Because other students have left, right?
Thanks, sir.
Okay, so I will make here one next thing that is nothing but the third small test is what it is a F test. Yes, so we are seeing the test. Why it is offering like this? I don't know. Test based on F distribution. Test based on F distribution. Right, now this test is nothing but the now understand one thing, right? This test is also called as this is the test for testing. Okay, test for testing equality of equality of population population variance. Here what we are doing, here we are testing equality of the two population variance. Now, what is the difference between this F test and that other test, whether it is T test or J test? What is the difference? Here we are testing the population variance, right? Now, that's the reason. What will be the hypothesis in this case? It is S naught equals to what? When I am considering the two populations, right? When I have the two populations. So, what are my populations? So, I am considering the first population, that is x1, x2 up to xn1, right? And y1, y2 up to yn2, right? Then I will check whether the variance of these two population are equal or not. When I am considering this t test and j test, I am considering the population mean. These are my test based on the population mean, and this is F distribution is using. I am using this F distribution for the okay testing the equality of the population variance. That means here uh, I am testing what sigma 1 square, right, equals to sigma 2 square or not. And here what I am doing, population mean, testing the equality of the population means what, mu 1 square equals to mu 2 square or not. So this is my h naught in this case, and this is my h naught in this case, right? So simply I can write here my null hypothesis will be what? It is h naught will be what? Sigma 1 square equals to sigma 2 square. Versus what will be my alternate hypothesis then? As we did before, right? It is not equals to greater and less, right? Sigma 1 square less than sigma 2 square and sigma 1 square greater than sigma
Greater
2
than.
square. Okay, alright. So this will be my null and alternative hypothesis. Now understand what is the meaning of F distribution, right? Now there is as we discussed, lots of distribution are there. Okay, so there is another one continuous distribution is there, which is called as the F distribution, right? So what is this F distribution now? So there is one definition of this F distribution. What is this F distribution? F distribution is nothing but it is the ratio of, okay, it is the ratio of two chi-square variate, two chi-square variables. Okay, it is the ratio of the two chi-square variables. That means, suppose my x is the variable which is following the chi-square distribution with something n1 degrees of freedom, and there is y variable which is following the chi-square distribution with n2 degrees of freedom. Then my f will follow what? That is, f is equals to what? It is the chi-square distribution. Okay, chi-square n1 divided by chi-square n2. That is nothing but the x by y. Then the ratio of these two chi-square variables is called as the F distribution. Okay, that is the simple definition of the F distribution, right? So this is, just understand this, because this may be asked in the MCQ. Okay, right? So this is exactly what is the F distribution, right? I think the degrees of freedom here, it is n minus 1 and n2 minus 1. So here, what I am doing, this chi-square n minus 1 is basically denoted by s1 square here. Okay, so I am considering the two population mean square, that is s1 square and s2 square. Okay, that is the first mean square for the first population is s1 square, and the mean square for the second population is s2 square. Then what is my s1 square? Again the formula will be what here in this case? It is summation of xi minus x bar bracket square divided by n minus 1, n1 minus 1. So this will become summation of xi square minus n into x bar square divided by n1 minus 1. Okay. And s2 square will be equals to what? It is summation of yi minus y bar bracket square divided by n2 minus 1, right? So this will become summation of what? Yi square minus n into y bar square divided by n2 minus 1, right? Then what will be my test statistic in this case then? Yes. So, so this is null hypothesis, alternate hypothesis, you already know, right? So in that case, I will get the null hypothesis. So my null hypothesis will be nothing but that is my test, sorry, my test statistic. Therefore, the test statistic is, so the test statistic is, it is denoted by F distribution with parameter, with parameter n1 minus 1, n2 minus 1. Okay, n1 minus 1, n2 minus 1. Okay, here it is not multiplication. Okay, understand that difference. In the chi-square, what happened? We are doing the multiplication of random variables, that is r minus 1 into s minus 1. Now here it is not, it is comma here. Okay, that means there are two degrees of freedom in this F distribution, and then equals to what? It is s1 square divided by s2 square. Okay, so this will be your definition of test statistic. Now when it is true, when we are using this test statistic, when your s1 square is greater than s2 square, understand that, right? When your s1 square is less than s2 square, then this distribution will follow, then it has the parameter, it has the different parameter, then it is n2 minus 1, n1 minus 1. So which is equals to what? In that case, we have to find s2 square divided by s1 square. Okay, that means whichever my s1 square is greater, I will put that s1 square in the numerator. Right, here it is my s2 square is greater, so I have put here s2 square, right? So here the test statistic, I have to decide the test statistic on the basis of the value of s1 square and s2 square. First I will check which value is greater, then my test statistic will be, right, will be decided according to the value of that s1 square and s2 square. Okay, now again, after finding the test statistic, you know that what is the next step. We have to take the decision, right? So what is the decision rule now? Okay, and I think it is again same as we have did before. If your value, right, if your z calculated value is greater than equals to f table value, means what? F n1 minus 1, n2 minus 1, alpha by 2. In the case of the two-sided hypothesis, then what we will do? Then you will reject the h naught. Otherwise, what we will do? Otherwise, accept h naught. Right? Same in the case of two-sided hypothesis also. Sorry, one-sided. Right? This is for the two-sided. If your f calculated is greater than equals to f n1 minus 1, n2 minus 1, right? Alpha, then we will reject the h naught. And what is third now? If your f calculated value is less than equals to, right, minus f. Now what is the meaning of minus f now? Yes, minus f means what? Minus f means it is f n1 minus 1, n2 minus 1, 1 minus alpha, right? Then also I will reject the h naught. This is the case of what? This is the case of when your sigma 1 square, sigma square is less than sigma 2 square. This is what? Sigma square greater than sigma 2 square. And this is the case of sigma square not equals to sigma 2 square, right? So this is the decision rule. Okay, so this is all the theoretical part of this f test, right? Now we will see one example on the basis of this f test, and then we will stop here. And I think I will tell you what is the timing of the your evening class now. Okay, how can I firstly, how can I decide whether it is example of F distribution or not, right? The F test or not, right? So that will be I get by using the by seeing the example, right? So here you can see that here test whether the population, the two population from where these two samples are drawn from the same variance or not. They are given that we have to check whether it is from the same variance or not. And here you can see that the variance test is only used for the f distribution. So that means this example is basically used for the f distributions, right? So that the reason our null hypothesis will be what? It is just not will be equals to what? Sigma 1 square equals to sigma 2 square, right? Versus alternative hypothesis will be what? It is sigma 1 square not equals to sigma 2 square, right? So this is my null and alternative hypothesis. Okay, so here I am doing one thing, that is for making the calculation simple. Okay, now here we want, now what is your test statistic? In this case we know that test statistic is f is equals to s1 square upon s2 square, right? Now for that purpose, to decide the test statistic also, I have to find this s1 square and s2 square first, and then I will decide the test statistic, right? Which will be your numerator, right? Now for finding this s1 square s2 square values, I will, for me making this that is this calculation simple, I am doing one thing, that is I am subtracting all that x value, right? Now x values are given, right? So what are that values? it is 60, right? 60, 67, 75,
Sir,
82.
66.
Oh, sorry, 66, 82, 84, 88, 90, right? Okay, so these are all the values of x, right? So what I am doing, I am subtracting that all the value from 80, right? So what will be my first value then? It will be minus 14, right? Next is what? Minus 13, minus 5, 2, 4, 8, and yes, 10, right? I think 92 is remaining. Yes, we will also take that values. Okay. Now, what is the formula of S1 square? Just 2 minutes. Huh? 90,
Sir, how
90, 92. Yes, 76. Okay.
sir,
Now,
sir, hello, sir.
yes, yes, yes.
How you calculate minus xi?
Minus x, I am just subtracting this value, right? This x, that all the values I am subtracting from 80. Understand? It
Okay,
is not minus xi. That I am
okay,
just considering these values. Okay. Just for
okay.
making calculation simple. Okay. There is no any other thing. Okay. Now understand this thing. Okay. Why I am calculating this xi? Why I am doing xi square? Okay. That is most important. Now I am putting the value of yi here. So what are the values of yi? 64, 66, 74, 78, 82, 85, 87, 92, 93, 95, and 97. Now here also I have to subtract these all yi values from. Okay, so that's the reason these are actually minus value of xi minus. Okay, because I am subtracting this value from, it is xi minus 80. Okay, this column of xi minus 80, and my next column will be of what? That is this column. This will be my yi minus, I am also subtracting this value from the just mean of that all values. Okay, it is 83. Y minus y, right? Because this, if you do the square of this value, so it become very large number, right? And for making that calculation simple, I am just subtracting the value, right, to make the calculation simple. Okay, and I am finding y square here also. Now, why I remain this value x square? Why I want this value now? Because I have to find s1 square, s2 square. And you know that. What is the formula of that s1 square? Yes, what is s1 square?
Summation of x1 minus x
Right.
bar.
Summation of xi square minus n x bar square upon n1 minus 1. And s2 square is what? Summation of yi square minus ny bar square upon n2 minus 1, right? So for that, right, I want this summation xi square, summation of xi square. That's the reason I am finding this xi square. Okay. Yes, do the same thing now. It is 12, right? 92 minus 80, 12, minus 76 will be what? Is 76 is number is there or not? I think 76 is not there. Yes, it is there. Okay. Yes, what will be that value then? It is minus 4, right? Minus 4. Now find the just a square of that all numbers. Before that, we are doing here again. Okay, minus 83. 64 minus 83 is what? Minus 90, right? 17. It is minus 1, right? It is 2, 23 plus 4, right? 4, and this will be 9. 9, 10, 12, and again 83 minus 70. 97 equals to what? 40, right? And find the square of this number now. Yes, what is the first square? 196. Second, yes, tell me squares. 169, right? 2 2, sorry, here it is 25, 4, 16, 64, 100, 144, right? 16. Here these squares are what? 361, 89, 81, 25, 1, 4, 16, 81, 100, 144. Okay, and yes, this number square, 40 square is what?
196.
196. Okay, right. Now find out this sum. Okay, now here this sum we get is 374, and this sum is what? This is summation of x square, right? And this is summation of y square equals to what? It is 1298. Okay, so these two sum I get here. Okay, so easily I can find out the s1 square and s2 square from that then, right? Here it is x bar square. Okay, let's substitute that value, right? So it will become s1 square equals to what? It is 734 minus n1 means what? How many values are there in the n1? 1 2 3 4 5 6 7 8 9 values, right? So 9 into x bar means what? That is the mean we have to also find, right? This mean, I think mean also we have to take of these values, right? Right, so that just find out that mean, right? That means that value, right? X bar square divided by n1 minus 1 means what? That 9 minus 1, which is 8. Okay, s2 square is also same, which is this value, right? 1296 minus n2 is what? How many values? I think two values are larger there, right? So it is 11 values, and y bar square divided by, it is n2 minus 1, that means 10, right? So what I am getting then, so after doing all this calculation, here s1 square will be equals to 91.75, and s2 square will be equals to 129.8, right? So these are my values of s1 square and s2 square. Then tell me what will be the test statistic then? Yes, what is the test statistic?
S1 square upon S2 square.
S1 square upon s2 square or s2 square upon s1 square? Yes. Is this or
Yes, sir.
this?
S2 square upon S1 square.
Right, this will be your
S2 is
test
greater than
statistic.
S1.
Right, because here your s2, right? So we can say that since s2 square is greater than s1 square, so test statistic will be what? It is s2 square divided by s1 square. And also your degrees of freedom is also changing, right? So it is f n2 minus 1 and n1 minus 1, right? Then, so yes, so we are just finding that value. So here your f statistic is what? It is f n2 minus 1, n1 minus 1 equals to what? 129.8 divided by 91.75, right? So this value, if you try to find out this value, then I will get this value which is equals to 1.415. Okay, so this is your value of f n2 minus 1 means what? 10, right? Because there is 11 degrees of freedom. 11 minus 1, 10, and 9 minus 1, 8, right? F 10, 8. Okay, now find out the critical value. So how to find, how you will find out? There is again, okay, you must remember, you have to must understand that how to find out this table value. There are different tables, okay, which are we have given in the statistical tables. You have to buy that statistical table, okay, you will get in this that in the market. In that, right, so in that what happened, you will get that is different, okay, this table as we have discussed, right, how to find in the values in the normal table. You will also get the table of the t distribution, right? So in that there are some level of significance are given, right? Here in the alpha the values of degrees of freedom are given, that is 1 2 3 4 5, and here the values of alpha is given 0.01 0.02, right? So this is how we have to find the value in the t table. How to find the values in the f table now? F table for for finding the value. Now here we have 2 degrees of freedom, right? So for that purpose they have given you, and now here they have given in the this side they have given the value of n1. Here they have given the value of n2, and they have given this table for the 0.05 and another one table for the 0.01, right? And then you can simply find out that particular, right, table value simply. Okay, right. Yes, so here we have to find which value in the table. It is F10 8 0.05. That means what? Here there will be some number, okay? That is 1, 2, 3, 4, 5, 10. And here it will be number that is 1 to up to 1, 2, 3, 4, something 8. Okay. So here you will get that table value. Okay. So this value, if you try to find this value in the statistical table, then you will get this value which is equals to again, it is 1.4, sorry, 3.36. Okay, 3.36, right? And tell me what will be your decision then? Yes, what will be your decision? Accept or reject? Yes, this is the last example now. Okay, all that test.
Sir, reject.
How reject? Okay, decision rule is same for all. When we will reject and we will accept, otherwise remember that when your calculated value, that means when your test statistic value, right, which we have calculated in the case of chi-square or t or z test, whatever that, your calculated value is greater than table value, then what we will do? Then we will reject h naught, then we will reject the null hypothesis. But here your calculated value is what? It is 1.4, right, which is smaller than this, right? Here your f calculated is less than f table. This is your table value, this is calculated value. The value you are getting for test statistic is called as the calculated value. The value you are finding from table, it is called as the table value. And now here this condition is not satisfied, right? Calculated value is greater than table value, right? Value is not greater, so we are accepting the h naught. Okay, right? We are accepting the S0. Now, if we are accepting the S0, then tell me what will be the conclusion? Yes, what will be the conclusion? We are accepting the S0. Yes, what is the conclusion? Accepting the S0 means what? Sigma 1 square equals to sigma 2 square, right? Accepting this null hypothesis, H0, sigma 1 square equals to sigma 2. That means this condition is true. This condition means true means what? Here they are asking in the question, that is just test whether these population variance are same or not. So our conclusion will be what? That, so we can conclude that the two samples are drawn from the same variance, right? The two population have the same variances, right? So this will be your, yes, this will be your conclusion. This will be your final answer. Okay. In this test, if you,
Okay, sir.
yes, if this kind of the example is asked in the example, always remember that the mark system will be, that is, this one mark will be for this defining null hypothesis, alternative hypothesis, right? After that, I think 3 mark. Okay, after that 3 marks will be for this calculation all and finding this test statistic, right? Test statistic. For that you have 3 marks. 1 mark again. 1 mark for the decision, taking the correct decision, whether accept or reject. And after that, 1 mark, that is the one last mark, will be for what? For the conclusion, theoretical conclusion, right? On the basis of this acceptance, what he will do? Accepting means what? This condition, that means the variance are the equal, right? So this is how you have to solve this type of the all the testing examples. Okay, right? So here we have covered our the last test, that is nothing but the F test, which is our the last, that is the third small test, right? And here also
No,
we
sir.
have, yes,
Can you scroll down this example?
okay, let's go. Yes,
Can you explain this 3.36 from where it came?
3.36, yeah, okay, this table value, huh? Okay,
Yes.
in this table value you are you want, right? Now, for that purpose, what you have to do, you have to firstly this value, this table value we are getting from the tables, right? You also remember that we are finding the table value of normal distribution, right? From the normal
Yeah.
table, right? The same there is another one table for the F distribution also. Okay, right? There is again
Okay.
one table that is for the F distribution. Now, how this table is given? Okay, suppose this is the F table. Okay, now there is 2 pages. Now there is, suppose it is for alpha 0.05. Okay, there is these pages is given alpha 0.05. Now what they have given you? They have given here n1 values. Okay, that means 1, 2, 3, 4, right? 5, 6, 7, 8, 9, 10. And here they have given n2 values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this one all values, right? I think up to 30 value they have given, because this is the small sample test, right? Your sample space must be less than 30. And now here which value you have to find now in this case? It is now this value is n2. Okay, right? It is n2 minus 1 and n1 minus 1, right? Yes, sorry, this will be n1 n2 only. Okay, so it is 10 and 8, right? And 0.05 it is already given, right? This is just the table of only 0.05, right? So there is no any need to check the alpha here. Just find the degrees of freedom. So first n1 value is 10. So firstly we'll check here. It is 10, and second n2 is 9. So here it is, right? So this value, right? Here you will get you some value. So this will be your value of that. Okay, that is, this will be your table value, that is F10 what 9 or 8 is there. Sorry, 8 is 8. Okay, so this will be that value. This value here you will get one alpha. Okay,
Okay, sir.
okay, understood now, right? So this is the value of
Yes.
F10 8 0.05, right? This value is what? It is 3.36. Here you will get this value 3.36. Okay. So for that I am telling you lots of time, that is just bought the that statistical table, okay, because it is useful in your examination, right? And it is allowed, okay, in your examination. So no any issue with that. Okay. So this is your last test. That is nothing but the what EF test, right? First was your t test, chi-square test, and F test. So these are all the small sample